So percent application, we are looking at all different kinds of percentage problems. Some that we did yesterday and then some that are new. I'm going to show you the ones that we did yesterday in a little different method. So we're going to start it with a markup. And a markup is the percent that's added on to the wholesale cost. So a store goes and buys their items from the producers or the manufacturers. They pay a wholesale cost, and then they put a markup on it so that they make a profit. Now, what I want you to think about is this. For this example where the cost of an MP3 player is $129.50, this is 100% of the cost that they paid. Then they're going to add a 60% markup. So altogether, you're going to end up paying 160% of the $129.50. You pay the 100% cost they paid, plus you're going to charge. You're going to pay the 60% markup that the store needs to earn a profit. So 100% plus 60%. Well, you're going to pay 160% of $129.50. So for the 160%, remember we move the decimal over 2 places. So you're going to take 1.6 of means times, and you're going to multiply it by that cost, $129.50. Okay, when we do this, 1.6 times $129.50 gives me 207.2. But we know we're talking about money, so $207.20 would be the final price of that MP3 player. So the difference from yesterday is I'm not finding the 60% and then taking that amount and adding it on. Instead, I'm doing the adding there at the beginning. 100% of the cost plus the 60% markup means I'm figuring 160% of the price. So I do one calculation there, and I've got the final answer. The second example, the oil change is $21.95, but we're going to charge a 65% markup. This cost is 100%, plus we're going to mark up 65%, so the total percentage we want here is 165% of the $21.95. Does everybody understand where I'm getting the 165%? 100% of the item plus the amount of the markup. So 165%. So I'm ready to write my problem now. I move my decimal over 2 places. 1.65 of means times $21.95. So 1.65 times $21.95. It comes out like this, 36.2175. But remember, we're talking money. Money has 2 decimal places. So I'm going to put a dollar sign, $36.20. Well, that 7 is the boss. It tells us what to do with the 1, and it would say go up, so 22 cents. $36.22 would be your final price with the 65% markup. Now we're going to look at discounts, and discount is the percent that's subtracted from a cost. Yesterday I showed you where you take the discount percent, multiply it with the dollar amount, and then subtract it away. But we're going to do something just slightly different. I want you to remember that when they give you a price, like the original price of a book, it's $18.50. That's 100% of the cost. We're discounting 45%. That means we're not going to pay 45% of it. So what percent are we going to pay? Rusty?
145%.
Nope, not 145. We're taking that off. You would actually take 100 minus 45. 55%. So we're going to pay 55%, so that's the problem that you will actually work out. 55% of $18.50. We did this in enrichment, just like this. So when I move my decimal over 2 places, 0.55 of means times 1850. So when I do 55% times 1850, it comes out to 10.175, but you know we're doing money, can't have 3 decimal places. So it would be $10, and the 5 tells the 7 to go up, so $10.18. Next, the original price of a telescope is $99.99. This is 100% of the cost. We are discounting 13%. That means we're taking 13% off. So what percent are we paying? 87. Good job. So 100 minus 13 makes it 87% of $99.99. And that's what we write our problem from. So 87% is 0.87 times $99.99. And when I do that, it comes out to this, 86.9913. But remember, again, it's money. So that definitely isn't going to stay like that. It's going to be $86.99. That one says stay the same. Tax is just like markup. It's a percentage added on to the cost of an item. Tax is the amount of money that you have to give the federal government or state government for items that you purchase. They get a little bit of a cut in the deal. So with example 1 of tax, original price of the book is $49.95. That again is 100% of the item. The tax, you're going to have to add on 3%. So you're going to want to find out 103% of $49.95. When you change 103% to a decimal, you move it over 2, so you would take 1.03 times $49.95. Okay, so 1.03 times $49.95, and it comes out to 51.4485. But again, you know we're doing money, so you only need 2 decimal places, and it would be $51.45 because the 8 would tell the 4 to go up. What?
Do you think this one's easier than
The second example, we have another book. It's $90.50. So that's 100% of the cost of the book. Plus, we're going to pay 4% tax. That means we're going to do 104% of $90.50. If you do 104%, then you would get the final cost in one calculation. So move the decimal over 2 places. 1.04 times $90.50. And it comes out to exactly $94.12. Questions about tax. Tax is just like markup. Add the percent onto 100. Take that times the dollar amount. That gets you your final price with the tax included. Questions about that? All right, next we're going to switch to interest Interest is, we did not do this yesterday. Interest can be good interest or bad interest. It's good if you're putting money in at the bank and the bank pays you a percentage of that amount of money for letting them keep your money there. They might use your money to loan it to somebody else and they're making interest off of them, but good interest is when you put money in at the bank in a savings account or something called a CD, and that's not what you play music on, it's called a certificate of deposit. You leave your money at the bank and they give you amount of money at your interest. Interest can be bad if you go to buy a house or a car or items that you don't have cash to pay for it. They'll let you take the item, but you have to pay them back plus interest, a percentage. So that's kind of the fee that you pay for getting to have stuff that you can't really pay for all at once. The way that you calculate interest, whether it's good or bad, is exactly the same. It is this formula, I equals P times R times T. So interest is a dollar amount that you can make off of the bank or what you pay the bank. It's a dollar amount. The principal is the dollar amount that is borrowed or invested. The rate is a percentage that you use as a decimal. And the time is in years. If they don't give you years, if they give you months, you have to change that over to time. So if they said 6 months, you wouldn't put 6 in there because that's not 6 years. 6 months, how much is 6 months of a year?
Well, half.
A half, so you'd put in 0.5 or a half. So you'd kind of adjust it, but just remember for time, they really mean years. So if it's not given in years, then you need to fix that. Okay, so this is an example where we have $2,300 at 7% interest for 9 years. So I'm going to write my formula down, and that's what I want you to do on your homework. I equals P times R times T. The principal is the dollar amount borrowed or invested. So from this example, my interest is going to be for the principal $2,300. The rate is 7%, but you know you don't ever really write the 7% in there. You write it as a decimal, 0.07, and the time is 9 years. This time they did give us years, so you are going to put in 9, and you multiply all that together, 2,300 times 0.07 times 9. That's $1,449. That's the amount of interest, but look what they want us to find right here. The ending balance. In other words, if you borrowed $2,300, you're paying back a lot more than that. You would pay back not only the $2,300, but add $1,449. So the ending balance would really be $3,749. So do principal times rate times time, find your interest. That amount is added on to the principal. That gets you your ending balance. All right, we've got one more. $43,800. You're borrowing at 4.8% interest for 2 years. So I'm going to use I equals P times R times T. I'm going to put 43,800 in for the principal. That 4.8% would be 0.048, and the time is 2 years. 43,800 times 0.048 times 2. That comes out to $4,204.80. I go back and add that to my 43,800 because that was my principal. So when I get done paying everything off, I'd pay $48,004.80.